In this question, it is given that nitrogen atoms had electronic configuration 1s7. 1s7. It would have energy lower than that of the normal ground state configuration. So we know that nitrogen atoms have configuration 1s2, 2s2, and 2p3. But if 1s7 would have been the configuration, the energy would have been less. But still 1s7 is not observed. Why? Because now we have to select the given options. Okay. So first of all, let's see what is the Heisenberg's uncertainty principle. Heisenberg's uncertainty principle states that for any object, its mass, for any object which is microscopic, its mass and velocity cannot be determined at once. Okay, so we cannot determine the mass and velocity simultaneously of a microscopic object. So Heisenberg's uncertainty principle is not related to the electronic configurations, hence this is not the correct option. Hund's rule, this is Hund's rule. Hund's rule of maximum multiplicity states that suppose I have any orbital, say I have p orbital, okay, and I have to fully fill this p orbital. Then what I'll have to do, I'll have to first fill electrons in each of the orbital, and then only I can start filling again, pairing the electrons. Okay, so first single electron goes in all the orbitals and then the pairing starts. This is Hund's rule of maximum multiplicity. Okay, again, this is not violated in 1s7 configuration because I can fill 7 electrons in 1s7, first in the same spin and then in the opposite spin. Okay, so this way I can fill. So Hund's rule of maximum multiplicity is also not violated. Okay, what is Pauli's exclusion principle? Pauli's exclusion principle states that in any s orbital or in any orbital, suppose this is one orbital of s or p or d or f or any of the orbitals or any of the subshells, then in this orbital I can fill maximum 2 electrons and not more than that. Okay, this is Pauli's exclusion principle, that in any single orbital only 2 electrons can be accommodated, and that too in opposite spin. 2 electrons and that too in opposite spin. Okay, opposite spin. So this way Pauli's exclusion principle is violated here. Okay, so the correct option for this question will be Pauli's exclusion principle. We cannot fill all the 7 electrons in s orbital, and thus we need to fill 2 electrons in 1s, 2s, and 2p. Okay, so this is the correct option.
Hello, here the question given is the wavelength associated with a gold ball weighing 200 grams and moving at a speed of 5 meters per hour is of the order. So here we have to find the de Broglie wavelength which associates wavelength associated with every particle of a particular mass n and moving with a velocity v. So de Broglie wavelength is given as lambda, which is equals to h divided by mv. Hence, h is the Planck's constant, and it has a value of 6.62 into 10 raised to minus 34. We have been given the values of m, which is 200 grams. In SI, it is 0.2 kilogram, and velocity of 5 meter per hour, which is equals to 5 into, this is given in meters per hour. To find in meters per second, we have to convert hour to seconds, which is, this is 5 meters per hour. So 5 divided by 3600 meters per second. Hence, lambda would be equals to 6.62 into 10 raised to minus 34 divided by mass into V, just 23600. So this is 6.62 into 36 into 10 raised to minus 32. And this is equals to 238.32. 238.32 into 10 raised to minus 32. This we can write as 2.3 into 10 raised to minus 30. So this is the answer. So this is of the order of 10 raised to minus 30. So order is 10 raised to minus 30. This is the answer. So the answer is order 10 raised to minus 30. This is the option C. Thank you. Here, the given question is, the number of total planes in a px orbital is. So, nodal planes are planes where probability to find an electron is minimal. In case of p orbitals have a loop shape like this. So the plane which passes through the center is having zero probability for finding electrons. This is the nodal plane. Nodal plane of p orbitals. There are a total of three nodal planes for p orbital, and these are present one each in px, py and pz. Therefore, answer would be 1. So 1 is present in px, this is px, 1 would be present in py and 1 in pz. So this is pz, then 1 would be present along py. So there are three nodal planes. So in a px orbital, it would be 1. So answer is 1. Thank you.
Hi guys, हमें यहाँ पे क्वेश्चन दे रखा है द इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ एन एलिमेंट इज, यानी हमें इलेक्ट्रॉनिक कॉन्फ़िगरेशन बता रखी है और हमें बताना है कि ये ग्राउंड स्टेट में, एक्साइटेड स्टेट में, कैटायनिक फॉर्म में, किस फॉर्म में. ओके, सो इसकी देखते हैं. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 और 4s1. अगर उसमें ये होता तो उसमें क्या होता कि इसका इलेक्ट्रॉन कम ये नहीं होता. ये कॉन्फ़िगरेशन किसकी होती है? ये कॉन्फ़िगरेशन क्रोमियम की होती है, CR2. ओके, तो ये कॉन्फ़िगरेशन क्रोमियम की होती है. क्रोमियम की कॉन्फ़िगरेशन एक स्टेट में होती है, ग्राउंड स्टेट में. ये क्यों होता है? क्योंकि वो इलेक्ट्रॉन पॉलिश रूल को फॉलो करता है या वायलेट करता है, तो वो एक्साइटेड स्टेट में चला जाता है ताकि उधर वो हाफ फिल्ड हो जाए. इधर तो वो पूरा फुल फिल नहीं हो रहा था, तो उधर उसको ज़्यादा अमाउंट ऑफ एनर्जी मिलती है. तो क्या होता है, वो एक एस ऑर्बिट का इलेक्ट्रॉन डी ऑर्बिट में चला जाता है, उसका माइग्रेशन हो जाता है. तो ये ऐसा कुछ कॉन्फ़िगरेशन होती है. उसकी 4s2 होता है, होनी तो ये चाहिए होती है 4s2. ये कॉन्फ़िगरेशन होनी चाहिए, चॉइस इलेक्ट्रॉन होता है. ये कॉन्फ़िगरेशन होती है, पर ये वाला इलेक्ट्रॉन इसको फुलफिल करने के कारण जाता है. सो इसमें ये हो जाता है, सॉरी, हाफ फिल्ड करने जाता है, हाफ फिल्ड हो जाता है, इसलिए उसकी एनर्जी बढ़ जाती है. सो उसकी वजह से करंट कर लेता है. सो इसका ये कॉन्फ़िगरेशन बन जाती है. सो बस ये वाली स्टेट किस में होती है? क्रोमियम की ग्राउंड स्टेट में ही होती है, ग्राउंड स्टेट में. ओके, थैंक यू गाइस, कीप सॉल्विंग. तो हमारे यहाँ पे आंसर क्या हो गया? आंसर नंबर बी, दैट इज ग्राउंड स्टेट. थैंक यू गाइस, कीप सॉल्विंग.
Hello students, question is the electron identified by quantum numbers n and l So first is n is equals to 4, L is equals to 1, second is n is 4, L0, third is n3, L0 and fourth is n3, L1 can be placed in order of increasing energy. So in this question we are given that electron that is identified by the quantum numbers, here n and L quantum numbers are given for 4 different configurations. We have to find out the increasing order of energy. So first of all, quantum number n is the principal energy, principal quantum number. Principal quantum number, and it describes the energy of the shell in which the electron is present. And second is given L. L is azimuthal quantum number. L is azimuthal quantum number, or it is also known as angular momentum quantum number. It tells us about the orbitals. It tells us about the orbitals, that is the type of orbitals that are present in the energy shell. So if L value is 0, it means the orbital is s orbital. If L value is 1, the orbital is p orbital. If L value is 2, the orbital is d orbital. And if L value is 3, then it is f orbital. So now we are given, first is n is equals to 4 and L value is 1. So n is 4, it is the energy shell, principal energy shell, and L value 1. So L value 1 means p orbital, it means this is the 4p orbital. Second is n value 4, L value 0. So if L value is 4, it means it is s orbital, so it is 4s orbital. Third is n value is 3, L is 0. N is 3, L is 0. So it will be L0, that means 3s orbital. And fourth is N3, L1. So it would be L1, that means this 3p orbital. Now we have to place them in increasing order of energy. So order of energy is decided on the basis of n plus L value. Order of energy, it is decided on the basis of n plus L value. If n plus L value is higher, it means the energy of that orbital is higher. So if we see here, n plus L value, in this case it is 4 plus 1, that is 5. In this case, n plus L value is 4 plus 0, it means it is 4. In this case, n plus L value is 3 plus 0, that means it is 3. And in last case, it is 3 plus 1, that is 4. And in those cases where the n plus L value, that is same, if n plus L value is same, then orbital with higher value of n will have higher energy. Orbital with higher value of n, it means its energy would be higher. Now in the two cases, n is equals to 4, L0, it is having n plus L value 4, and in this case n plus L value is 4. So in this case n value is 4 and in this case n value is 3. It means this is having the highest energy or higher energy than this because its n value is more. Therefore, the correct order of increasing energy of the given orbitals, then it will be the least energies of this orbital. So it will be 3. then this orbital, that is 3p, after that 4s, and after that it is 4p. So 3, 4, 2, 1 is the order. So this is given in the 3, 4, 2, 1, it is given in the second option. So B is the correct answer to this question. I hope you understood the solution. Thank you.